This is the video for repairing an iPod Classic 5th generation battery FPC connector. There are a few steps. First of all, that you obviously need to open it up. Usually this is caused by someone improperly disconnecting the battery from the battery connector. Once you open it up, you'll have to remove the headphone jack and the back chrome back, obviously, and then remove the hard drive, unclipping it. Also, as you can see, remove the LCD connection by flipping up the locking mechanism with a sharp object, but don't pry too hard. It should just flip up and hold it in place with your gloves. Remove the screws, as you see. Some parts of this video will be sped up, obviously, to save some time. But remove all 6 screws. Once the screws have been removed, you'll need to tape up the middle part of the click wheel so it doesn't fall out. The tape holds it in place. Go ahead and pry up on the metal portions of the frame, and you're just using it as a lever to separate the frame from the front face. Next step is on the 5th generation, there is some adhesive. Oh, well, here we go. Remove the hard drive flex cable, raising the locking mechanism. Once you remove the 5th gen, remove the taped grounding connector. I guess it's like a piece of tape, and it's taping down a piece of metal foil, which is grounding to the frame. So you'll need to gently pry that up. If you tear it, you'll have to recreate it with some metal foil. Cut the adhesive all along the edges, because you're going to end up having a hard time removing the logic board. So just cut the adhesive all along the frame to make it easier to remove the logic board. Place a sharp object between the frame and the logic board and just use it as a lever to pry it up. Now that it's off, you can see the damaged battery connector. All solder pads are still in place, which is good. If you find some that are ripped, they can generally be repaired. There's only the only way to not recover this is if you ripped, let's see, 5 of the connectors. Then it would be kind of difficult to create something. But even if 4, if you ripped 4 of them, it would be hard to recover those. 3 is okay, 2 is okay, even 1 rip connector is okay. Put some flux, no clean flux, on the old solder. We're going to introduce a different type of solder, so we want to remove the old solder, because sometimes different types of solder don't play well together, so we want to make sure that we place the same kind of solder on there. This is low melt solder that I am cutting into small pieces. And then with the flux in place, here's the damaged connector that the original owner mailed in. He thought maybe I could use it, but no, it's just I guess he just included it. But it was pretty badly damaged, so that's no problem at all. I have plenty of these. So here's the one bag of the new connectors that I have. One bag of many. The first connector I showed you was actually damaged also, so I just saw it, so I put it away. I'll fix that one later. But here's a new one. You have 5 points that can be soldered onto the logic board. So I'll put a piece of low melt solder. This lowers the melting point of the existing solder. There are some large solder pads. Always clean the tip, tin it, and then clean the tip, as you see here. And then rub or spread that low melt solder to all the old solder pads. The old solder softens it up. Now with soldering braid, clean it up. Always use fresh solder braid to remove the old solder. if you keep reusing the same braid, you're gonna have a hard time removing it. So always cut it short. There's plenty of it. And just remove this low melt solder that mixed in with the old solder. Now what we want to do is put some more flux, and we're going to introduce the new solder. This is essentially going to get rid of the low melt solder, so that way it's a strong joint when we put the new connection on. Otherwise, there's going to be a coating of the low melt solder still on there, and it's going to be a very weak joint. So, introducing this type of solder that I use to solder pretty much everything that I do. So now it's mixed in. Now we'll remove this new fresh solder with braid, and this will leave a coat of the new solder on the solder pads, and it will the new solder, when I go to solder the connection, will flow into it much easier since it's the same type of solder now. Again, mixing solder types is not good. Sometimes they don't play well. So I'll just put a little bit on the tip. Remember, clean your tip regularly. So I'm going to tin the connections on the connection. That way there's a little bit of solder on the connection itself already. Always tin those points. Sometimes it just doesn't take fresh solder, so it's better to do it beforehand. So I'm putting flux on the connection, and the hard part will be trying to solder this and keeping it in place. I use a microscope for this. It just allows me to have a better view of where those solder points are in relation to the connection. So it's a very tedious process, but it gets done. And if I mess it up, I just redo it. So I'm cutting tiny pieces of the solder that I showed you earlier, real small pieces with a razor, and I'm going to have them ready. I'm going to introduce them once I have the connection in place, and then I'll essentially put the soldering iron to it, and it should melt it, flow into the connection, assuming you cleaned all the joints and tinned the solder pads with the same type of solder that you're using. So here's the hard part, obviously trying to get the connection in the proper position and keeping it there while I introduce the soldering iron. It's essentially just to weld at least one point. Soldering one point will keep the entire connection in place, and that's all you really need to do initially, is just make contact with one point. Will keep it in place, will allow you to continue doing the other points on the one on the opposite side. Again, tedious. This takes a while. Sometimes these tweezers just don't work very well. So there's grabbing just a small piece of the solder with the spudger that has flux. So the flux allows me to grab the piece of solder, and then once I put it on the logic board, it releases it. You just got to find the right grasp with the tweezers, and then once you find it, it should be real easy to solder the connection on, as long as it stays in place. And of course, I'm messing with a microscope and making sure I can see the solder pad and the point. And this is slightly sped up a little bit. I should have sped it up a little bit more. So there's the soldered piece and soldering it on. I'm trying to get both points, but one point is good enough. I don't think I got 2 points. But that's the first point. The connector stays intact on the board and allows me to continue on with the next portion. To adjust the microscope to make sure that the solder went between the joint and the solder pad. Good connection. And it is. And then I'll move to the other side. I don't like to use solder paste. It's not very strong. It only has a 6-month shelf life, so I rarely use it. So then it ends up going bad. And then even then, if it's good solder paste, it's not a strong joint. It literally is like half the strength of regular solder. I'm not sure why. It's just tiny pieces of solder mixed with flux, but it's not very strong. I think it just oxidizes much faster. So never use paste on this unless it's very strong. I found paste just to be very weak. So introduce a small piece of solder, and I'm just trying to get the solder to flow into the solder pad and the joint. And it does, it's just it takes careful work. As long as you don't touch any other chips, you're fine. Sometimes you touch the plastic on the connector, it's no big deal. The plastic outside of the connector doesn't do anything. It's the inside of the connector that matters. And of course, as long as the pins are still intact, to make connection to the logic board. I used to do this without a microscope, and I just found it so much easier with one. And it's important to always maintain some kind of flux residue on there, since the flux allows the soldering to leave a very shiny, no oxidization connection. If you have no flux, you're going to have a very brittle cold joint. And the cold joint is not very shiny. It doesn't flow well. The flux allows the solder to flow into the joint. No flux, no flow. And you'll have a lot of oxidization. It'll look awful. Soldering, you need to go ahead and clean the connection so that you remove as much flux as you possibly can. Even though this is no clean flux, removing the messy residue is always good. I'm going to try to get a close-up of the solder joints. They should be nice and shiny. No cold or oxidized joint, because then it's not a good connection. You can see they're shiny. And there's the back side. And now in reverse order, you just reassemble. This is sped up to save a little bit of time. But there's that foil, the piece of grounding that you need to straighten out. Don't rip it, don't tear it. It needs to go back onto the frame. Once the logic board is in place, just fold it over. Adhesive that still remains, it should be good. Again, this is a 5th generation. The 6th generation has 2 screws that need to be replaced or removed, and also screwed back on once you assemble. This is the hard drive flex cable. It needs to go on. Slide it in. It only goes in one way. Once you line it up, close the locking mechanism. As far as the LCD front, put the flex cable over and put the logic board and frame in, and then the flex cable for the LCD slips right in. Use a plastic spudger. Never use a metal spudger because you could damage or tear the LCD flex cable. And then with the spudger, just fold over, or your finger, fold over the locking mechanism, and then slide it across to make sure that it's all the way down. Next should be the hard drive. Oh, I'm sorry, yeah, screwing in the frame to the front. Just to prevent the click wheel from sinking in, and the front face coming off also. Even without these screws, it should still stay intact, since it, I believe the back chrome locks into the plastic front, so everything kind of stays together. But still, I mean, they're there for a reason. You better replace them. These are just bumpers. They'll keep falling off until you're ready to put them back together. Hard drive is in is probably the best time. It should have adhesive on the back end that goes to the frame, but it gets dust and worn out. Now the hard drive flex cable, just kind of bend it out and slide it in. Make sure it only goes up all the way to the line. You see it's crooked. It needs to go all the way just like that. Make sure they're all the way in. Push with a spudger into the hard drive to make sure that they go as far as you possibly can. And then with a finger, I use my finger, and once it snaps down, use a spudger to make sure that it's all the way down. Next is the headphone jack lock cable. You need to go ahead and pull out those locking tabs with something sharp. Don't cut anything, but just kind of pull them out. It's what grabs to the front face or the frame. That way your iPod doesn't come apart. And then just bend the sides in with your hands. You could rub it up against something hard with a towel on it to kind of bend it in. You see how it's slightly bent in? Very slightly bent in. And then the top should be slightly bent in also. Just a little bit. That way it grabs and it's flush when you put it back together. And then that's the last locking mechanism that needs to be bent out, which will grab the top. Raise the locking mechanism for the headphone jack if it's not already raised. And with the tweezers, it looks like a 90-degree turn. That way it slides in. Don't worry about tearing with the tweezers. The cable, it's very thick. And that's the last piece. Now what you want to do is try, there's rubber around a hard drive, which you want to try to make sure that it sits down inside the frame. If it doesn't, just sneak it in with a spudger, kind of work it in there, or else it's not going to fit. The back chrome won't fit back. It will, but you'll have to force it in, which you don't really want to force anything in. So just try to make sure that the rubber surround is all the way down inside the frame. Now with a battery connector, you want to raise it back up, and you want to try to avoid damaging it. So you hold the white piece down with a spudger, and then with tweezers, serrated tweezers, you pull up on the locking mechanism. Raise it up to avoid damaging it again. It's very soft. So here it is back together. Or before I sealed it, I just want to make sure it charged, and it does charge. So the next and last step is to seal it up. As long as the hard drive is seated properly, everything should just snap in place. You should have flush all along the edges, nothing bent. If you did it right, you can't even tell it was opened. And then the last and final step, obviously, is to make sure it actually charges. Now these batteries will fluctuate. Obviously it was green a while ago, now it's red until it levels out. And there we go, it's charging. Send it in to ZFixit if you need this type of repair.